Guys, we made a mistake in our last video. I I hate to tell you, but our robot, it does have a tilt mechanism. The robot does indeed tilt. We lied to you in the last video. Apologies. We've tilted multiple times at competitions. It does tilt. For some reason we forgot about it. That's our bad. For our code this season, we've used multiple programming libraries. So this season we started with ftclib, which is a command-based system, and then we swapped over to solverslib, which is a maintained version, maintained fork of ftclib, because ftclib is no longer updated. Uh, it adds a couple more features right now, particularly commands that you can use with pedropathing. Another plus is that it adds the names for PlayStation buttons, so if you have those controllers, it adds a little bit more of continuity. We also use pedropathing for autonomous, which has proven to be really useful for us. We've used Roadrunner since PowerPlay through Into the Deep, and that had proved very successful for us in autonomous. But we've really taken it to the next step with 12 Artifact Auto and Collaborative Auto with the DCS Mech Warriors with pedropathing. And then we also use Marrow, which was made by the Team Skeleton Army. And we particularly use it for their zone detection system because we can use it to check if we are in the close or the far zone, and then move these HUDs into two different positions depending on what zone we are in to then have a better launch overall. So probably my favorite part of the robot this season is our dynamic velocity commands that we use. So our robot uses pedropathing and teleap, which is not something commonly heard of. So we're using the position tracking data from pedropathing and teleap to get coordinates from the field to then convert that into distance between us and the April tag, because Pedro has a distance from method. So we just got a distance or a pose for the goal and then told it to track the distance between itself and the goal. And then we created an equation using Microsoft Excel. So we took our robot and we lined it up to the goal, and then just started launching balls into it from specific distances and recorded the minimum velocity needed and the maximum velocity needed, and then took the average of those, and then basically just made an equation from those of what how our launch velocity should change as the distance goes up. And so, as we got along with our testing, we found that our uh, most recent equation has become a linear equation, which is very exciting compared to our previous equations, which were not linear whatsoever. Uh, and now, due to that equation, we can plug in the distance that we get from Pedro to then use that equation to turn the distance into a velocity. So then when we're rolling up to the launch zone, it's constantly updating the velocity while we're going. And so these launcher wheels, when we get in the launch zone and start to rest, are already spinning up or down to the speed that they need to be. And it's really helped for meet one, we had to sit and wait for our launchers to spin up every time, but this has sped up our cycle times a lot, just not having to wait for the launch wheels to spin up or down. So this season we used the Limelight 3A camera. In Autonomous, we used it for reading the obelisk to save the pattern for later, or save it for auto so then we can score without having to tell the robot what the pattern is. And then in teleap, we use it to align to the goals April tag. So the way we do that is that it gives us an X offset in degrees, and then we use that and feed it into a PID controller from solverslib. And then we use that to control the turning motor power in our chassis subsystem to control the robot's turning and align towards the April tag. And then our driver can just do that with the push of a button instead of having to try and figure out what angle they need to align to launch. They can just click the button and go, and it's improved our cycles a lot. So this season we have not one but two cameras on our robot. So inside the bottom of our robot we have a camera called an Ardu cam, and so what that camera is doing is it's looking inside each of these three slots in our transfer mechanisms, and then it has like 3 detection zones, quote unquote, to look for purple and green specifically. And so then when it has a ball in the different zones, it can check if it's purple or green, and then from there we have some logic to tell us what balls we have in the robot, and then we can also use that to tell our robot how to launch the pattern. So, for example, if the pattern's purple, purple, green, and it has 2 purple and 1 green, but like the purple or green's in the middle and the 2 purple on each side, it will still launch the first 2 purple simultaneously, even though they're not next to each other, and the green will launch in the middle. Uh, and then for Teleyap, we have these lights on the back that correspond to each transfer mechanism to tell us if they are green or purple. And then if there's not anything in that, uh, zone, then it changes to our alliance color, so blue or red in this case. But then we also have the automation to launch pattern or specific colors as well to work with our alliance partner. So, for example, say the pattern's purple, green, purple, and our alliance partner just launched a purple, we can just click a button to launch one green. And that's proven to be very helpful for us for getting the pattern ranking point in matches. We almost forgot something very important. This is about to turn into another apology video, which I did not want to have to cut and edit. Hit the lights! Underglow! So we added this as a just purely aesthetic piece, but our robot's name is Super Thwomp Rainbow, so it should have some sort of rainbow component to it. So we have some Go Build a Prism lights on the bottom. Very stylish, very fun. You know, it's probably an intimidation factor as well for a lot of teams. Uh, yeah, this is a very exciting addition to our robot. So overall, I think we have a pretty cool robot this year, programming wise and build wise. But you know, I'm a programmer, so of course it's gonna be mostly programming. Like the dynamic velocity, the limelight heading lock, adjustable hood. You know, our selector camera, lots of various cool features. So yeah, thanks for watching, and scream you later.